Trigonometry, Chapter 5, Trigonometric Identities, Section 3, Sum and Difference Identities, Video 3, Deriving the Sine, Sum and Difference Formulas. This series is based on content from Pearson's Trigonometry 12th edition by Lial, Hornsby, Schneider, and Daniels. In the previous videos, we derived the cosine sum and cosine difference formulas. Cosine of A minus B equals cosine of A cosine of B plus sine of A sine of B, and cosine of A plus B equals cosine A cosine B minus sine A sine B. Now we can write this as one formula. We can write cosine of A plus minus B equals cosine A cosine B minus plus sine A sine B. Now you've probably seen the plus minus before in the quadratic formula or elsewhere, but you may not have seen the minus plus before. The only time a minus plus is used is when there is already a plus minus somewhere else in the expression and the signs disagree. For example, when it's negative on the left, when it's minus on the left, it's plus on the right. When it's plus on the right, it's minus on the left. So to separate the formulas, you use either the top sign in each pair or the bottom sign in each pair. So either the plus and the minus or the minus and the plus. In this video, we derive similar formulas for the sign of a sum or difference. In other words, sine of A minus B equals something and sine of A plus B equals something. First, we will derive the formula for sine of A minus B. To accomplish this, we attempt to connect sine of A minus B to cosine of A minus B since we know that formula. Do you know any identities that connect sine and cosine? You should know at least one. Most likely, you were thinking about sine squared theta plus cosine squared theta is equal to 1, Pythagorean identity. If we went in this direction, we would start like this. Sine squared of A minus B plus cosine squared of A minus B is equal to 1. We would then substitute the formula for cosine of A minus B to get this. Okay, that was supposed to be different down there. I'm not going to pause the video, but it is right here. Okay, obviously I had an editing issue, but that's okay. We would substitute the formula for cosine of A minus B to get this. Sine squared of A minus B plus the square of cosine A cosine B plus sine A sine B is equal to 1. And again, just to make sure we're all on the same page, this is equal to this. But since the first thing I highlighted in yellow squared, so is the second thing. Now, we could try squaring this binomial, isolating the sine squared, and then taking the square root of both sides. I invite you to try this. However, when I asked, do you know any identities that connect sine and cosine, did you remember that there was another? Do you know what it is? The cofunction identities express a relationship between a function and its cofunction. Specifically, sine of theta equals cosine of pi over 2 minus theta, tangent of theta equals cotangent of pi over 2 minus theta, and secant of theta equals cosecant of pi over 2 minus theta. Recall that theta and pi minus 2 over theta are complements. In degrees, that's 90 degrees, so these are complements. So sine of theta is the cofunction of its complement. We use the first of these to establish a connection between sine of A minus B and cosine of A minus B. We're going to let theta equal A minus B in this cofunction identity. Now be careful. The second theta is part of a subtraction problem preceded by a minus. So we need parentheses around the A minus B to make sure we're subtracting the difference and not just the first term. But we're going to distribute the negative across the A minus B inside the cosine, which will make the A negative and the B positive. And now we're going to regroup the two terms inside the first two terms inside the cosine by just putting parentheses around them. Now, why would I want to do this? Because now this says cosine of a sum, cosine of pi over 2 minus A plus B. So we're going to apply the cosine addition formula. Cosine of A plus B equals cosine of A cosine of B minus sine A sine of B, but we're going to replace the A with pi over 2 minus A. So look very closely to see what we just did. We just applied the formula for cosine of A plus B to this expression here. And so everywhere there's a red A, it will become pi over 2 minus A. All the B's will stay the same. So cosine of pi over 2 minus A cosine of B minus sine of pi over 2 minus A sine of B. But now we can use cofunction identities on the two terms using pi over 2 minus A. Cosine of a complement equals sine of the original. So this should be sine of A. Sine of a complement equals cosine of the original. So, okay, it was a little anti-dramatic. So let's get a highlighter out. Let's put it in green. So this guy was this guy. Okay, maybe green wasn't the best choice there. Let's try that again. We'll do it with yellow. This guy, cosine of pi over 2 minus A, equals, and let's get rid of that. Let's get rid of that, please. Thank you. Equals this guy. So now let's go back and forth. Cofunction identity. That cosine equals that sine. And different color. We'll use orange. This guy, sine of pi over 2 minus A, is equal to this guy, cosine of A. Again, cofunction identity. And that's our sine difference formula. Sine of A minus B equals sine of A cosine of B minus cosine of A sine of B. I don't have a gimmick for it. To get the sine sum formula, we could rewrite A plus B as A minus negative B, then use the sine difference formula along with even odd identities like we did in the previous video. The end result is sine of A plus B equals sine of A cosine of B plus cosine of A sine of B. And these are your sine sum and sine difference formulas. And here's all of them. Now, the future calculus student wants to memorize all of these, but we can condense them into two formulas by using the pluses and the minuses, the plus minus and the minus pluses. Notice on the sign, they match. They're both plus minuses because here the signs match across. Either they're both minuses or they're both pluses. But on the cosine one, the first one is plus minus and the second is minus plus. It really doesn't matter which is which, but usually you bring in the plus minus first. They're opposite because the signs are opposite on either side of each identity. So there's your sum and difference identities for sine and cosine, which brings us to the end of 5.3.3, video 5.33.